The time has come, the war is said, to speak of kinematic equations. So the question is, what are kinematic equations? And kinematic means motion, so they are equations of motion. So we've dealt with a basic one, V is equal to change in D over change in T, or we often use that as D is equal to VT. But this does not take into account acceleration. This is only for a constant velocity. I cannot stress this enough. If you're going to have something accelerating, then we're going to need to expand this equation. So the quantities that we're dealing with, when we're dealing with kinematic equations, kinematics, we're dealing with 5 different quantities. We're dealing with initial velocity. We're dealing with VF, which is final velocity. Because the whole point is, if there's acceleration, there must be a change in velocity. So if we have acceleration, the velocity is going to change. So we've got a start amount, we've got a finish amount. There is going to be an acceleration, because this is the whole point of expanding this, is to include acceleration. This is going to take place over a distance. Unlike movies and things like this, acceleration, change of velocity takes time, it takes distance. And that's the other thing we're going to need. We're going to need time, T for time. So what we actually have is we have a set of 4 equations which we use, which are the general kinematic equations. And these equations are going to have each equation will have 4 of these quantities. Each will be missing 1. And if we know any 3 of these quantities, if I know initial velocity, final velocity, I can work out the other 2. So if I know these 3, VI, VFA, I can work out D and I can work out T. And we'll do that in examples. So what are the kinematic equations? Well, as we're saying, there's a change in velocity. VF, VI plus AT. Sorry about the background noise. So the final velocity, we take our start velocity, and then we take our acceleration and we multiply that by time and we add that to our velocity, give our final velocity. So it seems reasonable. I'm driving down the road at, I don't know, 20 meters per second. I accelerate, so I speed up, and I add that velocity change to that. So remember, what else have we got? We've got D equals VIT. Notice this is basically this equation, but we now have to add on a term for the change in velocity, or for the acceleration, plus half AT squared. This is a fairly standard equation that's used a lot, especially in things like dragsters and things. If we are parked, if the initial velocity is 0, we can get rid of that, because 0 times anything is equal to 0. So often you'll just see it as D is equal to half AT squared. This is hard to rearrange for T, this equation. Okay, the other ones, D is equal to VI plus VF over 2. So D is equal to the average velocity times the time. So instead of using the velocity, we take the average velocity. So D is equal to the average velocity times the time. The way we work out the average is we take the initial amount, the final amount, and we divide by the number of things too. So that's how we do averages. And the fourth one is VF squared, the final velocity squared, equals the initial velocity squared plus twice times the acceleration times the distance. That one's a little more difficult to explain, but how it works, but it does work. So you'll notice, as I said, each of these equations has 4 out of these 5. So this has final velocity, initial velocity, acceleration time. but this one does not have distance. So if you don't know the distance, just don't use that one. This one has distance, initial velocity, time, and acceleration. Sorry, it's got distance, velocity, initial, acceleration, time. This one does not have final velocity. So distance is equal, so this one has distance, velocity initial, velocity final, and time. So this one we don't need to know, what are we missing? The acceleration. We don't know the acceleration, but we can still work out the distance. And this one, the final one, has final velocity, initial velocity, it's got acceleration, it's got distance, but it does not have time. So, as I was saying, if you have an equation like this, if you know 3 things out of the 4, you can work out the 4th. So let's do an example. I'm driving down the road. I'm driving at 10 meters per second and accelerate at 2 meters per second squared for 10 seconds, 15 seconds, 15 seconds. What is my final velocity? And what is the distance travelled? So we do the usual thing. We draw a picture, me in a car. Cannot stress this enough. The more of your brain that you use on a problem, the more effective it's going to be at solving the problem. What do I know? I know the initial velocity. My start velocity was VI equals 10 meters per second. I do not know my final velocity. What else have we got? We've got acceleration equals 2 meters per second squared. Okay, so I'm speeding up. I don't know my distance. That's one thing I have to find out. But I do know my time. Oops, which is equal to, one blank there, 15 seconds. Okay, so let's try this. I know 3 of these things. I can work out the other 2. So I'm going to look for an equation that is VI, A, T in it, and has one of these 2. And that's going to be this one, VI plus A, T, VF. So VF equals VI plus AT. Don't even have to rearrange this one. Equals 10 meters per second plus 2 meters per second squared for 10 seconds, 15 seconds, equals 2 times 15 is 30 plus 10, 40 meters per second. Oops, I am way over the speed limit there. Hopefully there's no traffic cops around. Okay, so I now know this one, 40 meters per second. What's the distance travelled? Well, I can choose this one because I know VI, I know T, I know A, I know T squared. I'm going to use this one because compared to that one I don't have to do a square. So D equals VI plus VF, take the average, times the time. VI is 10 meters per second plus VF is 40 meters per second. Divide that by 2, so 25 times 15 seconds. That's equal to 25 per second times 15 seconds. 25, 15. That's at 10, 15, 17, 375 equals 375 meters. So I basically put down my foot on the accelerator, I speed up, I break the speed limit. I end up at 40 meters per second, and which is 120 something kilometers per hour, and I end up at 375 meters to do this. So I will do another video shortly with more examples, but the big thing is there's 4 equations. There are these 5 quantities in these equations. Each equation has 4 things, has one of these missing. So therefore, if you know 3 things in each equation, you can work out the missing thing. And that means if you know 3 of these quantities, you can work out the other 2.